So that last song was actually one of the finale songs. There are about 5 of them from Return of the King that was released a couple years ago. Okay, so a couple announcements. As I said, lab scheduling issues are pretty much all resolved. This will probably pop up on the slides for the next couple announcements, mostly because this really excites me, because last semester we had, at this point in the semester, there were still 50 people who weren't sorted into labs. So the fact that it's only 3 people that aren't sorted into labs is very exciting. Clickers. So as promised, I installed the software, all ready to use it, and in addition to crashing my computer every time it reboots, the license code that they gave me isn't working, and now it's preventing me from connecting to the wireless network. But, essentially the moral of the story is that we can't use clickers today. I'm going to call and have a couple discussions with the technical staff of this company. The first homework is out today. I'm going to spend some time going over it. We have a lot to get to. At one point or another, we will get to all the stuff that is covered by the homework today in lecture. Monday's lecture, I'm going to go over an example called BMI calculator. I don't think I'll get to it today. And in that lecture, it should become even a bit more clear as to what we want for the homework. So, if you go to our website, on the homeworks page, right here we go, is homework 1. And essentially this program there's sort of 3 main parts. It's going to ask the user for input, it's going to do some computations, and it's going to spit out some output. In particular, the program, the formula that you are going to implement this semester is computing the weekday from the date. So given a date such as February 2nd, 2007, which is when this homework is due, it will tell you that that happens to be, not surprisingly, a Friday. And we have this kind of long-winded formula that deals with it. So it turns out that the reason this formula is so long has to do with leap years. It used to be that leap year was every 4 years. No matter what happened, every 4 years was a leap year. And it turned out that that's actually not exactly accurate. Leap years are really every 4 years, but not every 100 years. So like 1900, 1800 are not leap years, but they are every 400 years, so 2000 was. And most of Europe didn't implement this until the 1500s, and by that point, the whole calendar had started sliding, and it was snowing in September. Well, not quite that bad, but so this is why this formula is nice and long and complicated. In particular, what the user is asked for is the year, the day, and the month, although not in that order. So they're asked for those 3 things, and those values are stuck into this formula. In particular, you have to figure out the century. 2007, the century is 20. Okay, 21st, we're going to ignore that. It's just the first 2 digits of the year, and then the year part, which is in the middle of that, is the last 2 digits of the year. So 1995, the year part would be just 95. The interesting thing here, and this is very, very, very important, because if you don't do this, you're going to run into lots of problems. If you want to enter January, that's actually entered as month 13 of the previous year. If you want to enter February, that's entered as month 14 of the previous year. March is entered as month 3 of the current year. Now, there are certainly ways around this, and obviously computer programs can figure this out. We haven't actually seen the control logic to do that yet. So for this homework, when you want to enter February 2nd, 2007, it has to be month 14, day 2, year 2006. So just keep that in mind when you're actually testing it out. So, et cetera, we have a sample execution. This is what the program version that I wrote did. In particular, these are the values that were entered when I ran it. And then to give you some testing data, we have some very important dates in history listed there. So, in terms of steps to do this program, there's 2 things that I want to direct you to. The first is we list pretty much the 5 steps that one has to do in order to complete this. Print out a legend, get input, do computations, do output, slightly expanded in those 5 bulleted or numbered points right there. The other thing I want to direct you to is a program called BMI Calculator. This program, we may get to it today depending on how rapidly I can talk. But if not, we'll be getting into Monday. And it is a fairly similar type of program in that it asks for input, does some computations, and then spits out some output. So going over that, we have some long-winded essays about why computer science is great, et cetera, et cetera. Two things I want to mention here. If your program is computing the wrong day of the week, so it works, it spits out a value, but it's telling you today is Wednesday when it's really Friday. We have a couple ideas as to things that might be going wrong. As myself and the TAs and Professor Coe were typing this up, we kept mistyping the formula slightly. So we took that and made the top bulleted list right there in hopes that it will solve some of your frustration when going through that. We also have good programming practices. These are things that you must include in each program. Things like your name, email, and section need to be at the top. We want to make, should be well commented, et cetera, et cetera. These are things that are going to have to be in every program. We're going to be pretty strict about it. And it basically goes and lists those in great detail. For this first homework, we will tell you what things we are looking at to grade it. I don't know the point values for it because I haven't figured that out, and I probably won't know that until after the homework is turned in. But those are the things that we're going to look at for this homework in terms of grading it. I'm not going to be releasing that for every homework, certainly, but for the first homework, to give you an idea of the stuff we're looking for, it's all listed there. And then when you're all finished, you can go through and submit it. And you'll notice when you submit it, we have a whole series of questions that we'd like to ask. Things like, how difficult was it? How interesting was it? This feedback is really important to me because it allows us to judge the assignments. And if we release an assignment that's the most interesting thing ever since sliced bread, well, then we can go about and start replicating that assignment and make more interesting ones. If it's way too hard or way too easy, then I'll adapt appropriately as well. Questions, comments, or concerns? So this, no, don't do this. Okay. I always have to have a backup plan with Windows. So this was the last slide that we dealt with, and we talked about going through and printing it. Is it still hung? Yeah. All right. Okay, so I want to spend some time talking about methods. And let me stick my remote into this computer. Give me a second. I'll have you know that the fact that my computer is blowing up is because I installed the clicker software. Seriously, I mean, that's literally the only software I've probably installed in the last 3 months, and suddenly everything stops working. So, I want to spend some time talking about methods and functions. You've seen a good amount of this in the last lab. The last lab that you did all yesterday went through and did a number of things, such as figuring out the square root, figuring out the log, figuring out various other aspects. And these are things that in normal math are called functions, but in Java we tend to call them methods, for reasons we'll see in a minute. So we can think of a lot of mathematical functions, many of which we've seen yesterday in the lab. The sine, the cosine, the square root, the tangent, the log, you get the idea. And what they do is they all take an input. These three angles all take the input of an angle, 90 degrees or radians, that version of radians, whatever it is, and then output or return whatever the sine is or the cosine is. So again, you can think of them as a mini program. And it's taking in some value or some sort of input and returning or giving you back some sort of output or the angle. I'm sorry, the sine or the cosine. So the way Java works, and we're going to see exactly why it works that way, is it happens to be math.sine, math.cosine, and math.tan. And essentially that's saying, from the math library, I'm going to use the sine method, the cosine method, or the tangent method. Let's see if I can enter my password. So this is the lab that we actually did yesterday. And in particular, you see, double y, no, we're going here. Double square root x equals math dot square root x. So what that's doing is x has already been inputted by the user. It's going through and passing that value x to the square root method. So the square root method is then going to compute somehow. We don't know how it works, and at least as far as this class is concerned, we really don't care. It's going to compute the square root of x and then return it. So then square root of x, that variable, that one there, is then going to have the square root of whatever value is inputted. Now, there are times when functions may not work properly. If you enter a negative value for x, then the square root of a negative value, you're running into problems. In particular, you're going to have to do with complex numbers, which doubles can't handle. So here we are using a particular method or a particular function. Later in the course, we're going to see exactly how to start writing these all by ourselves. Here's another method that we have. Double y equals standard in dot next double. And I'm going to spend some time talking about that in a moment. But essentially what we want to do for a lot of programs is we want to be able to read in text from the keyboard. There are two things that are needed for this. First, we need scanner standard in equals new scanner system.in. Now, the term STDIN, that's just a name. You can name it anything you want. Friend, foo, bar, whatever. The rest of it has to look exactly like that. Essentially, scanner is something that's created by Java, that's already been written for us, that allows a really easy means to read in input from the keyboard. So anytime we then want to read in something from the keyboard, we just say standard in, and this name needs to be the same as that name, dot next double, or dot next int, depending on what we want to read in. As far as this homework is concerned, we only need integers. All right. So that's the quick lowdown on methods or functions. Some do require what's called a parameter. Some do not. The exact details about which ones do and which ones don't, we're going to see that in a little bit. All right. Yes, 1 second. Oops. And I think I now have this working. Yes, question?
Do you have to capitalize when you put next double? Do you have to capitalize
So in terms of capitalization, the capitalization is fairly important in terms of the only thing here in this line that can be changed for the capitalization is this. And whatever you name that needs to also be named that. For next double and next int, Java knows it as all lowercase with the exception of the D being capitalized. So yes, you also have to make sure that you capitalize it exactly as such. You try next double all lowercase, so the D is lowercase, then Java's not going to realize what function it is.
So if you want to have something have input from the keyboard, all you do is type what you want, like the input that you want, like double F, and then just type it into that line, and see what you get.
So first you have to put that line at some point, and then you have lines that look similar to that. And then, yes, you could get input from the keyboard. I have another couple slides. I'm actually going to expand on this in a bit. But yes, essentially, anytime you want to get input from the keyboard, and there's one or two other things that are needed that I'm going to spend a bit of time on. But essentially, this line needs to be towards the beginning of your program, and that line needs to be somewhere else in the middle. And then you can get input from the keyboard. Yes? Next, essentially, it's saying get the next double from the keyboard, or get the next int from the keyboard. That's just what they called it, meaning that it's going to sit there and wait for the user to enter the next integer he, she wants to enter before it allows it to continue. We're going to spend a bit more time on this, so I'll be coming back to it, like right now. So this is obviously pretty important because we want to be able to use programs where we can enter values. One of the examples, the first example I'm going to give is a temperature conversion. And it converts a fixed temperature, like 28 degrees, which is great if it's 28 degrees out, but if it's not 28 degrees, then that program becomes of much more limited use. What we want eventually is a program that could read in a value from the keyboard and convert that temperature, or read in the dates from the keyboard and convert that to the weekday. So that's temperature conversion that we're going to see in a couple slides. We're also going to see body mass index. Body mass index is essentially a ratio of your height to your weight, and it tells whether or not you're, the idea is it's supposed to tell how healthy you are, and if you're over a certain number, you're obese. But Michael Jordan, in the height of his academic prowess, was considered obese according to the body mass index, so it's not really the most accurate of measurements. Okay, reading in a value from the keyboard. In particular, to read in values from the keyboard, first you have to create a scanner object. I'm kind of ignoring exactly what an object is at this point, but you have to create one nonetheless. But you don't worry about what an object is or what a scanner is or how to create them. For now, just memorize this line must be at the top of your code. And that's the line I mentioned before. Again, so we use stdin because the keyboard is sort of the standard way of interacting with the computer. So it's the standard means of input, or standard input, or stdin. So when I read that, I'm actually going to just call it standard in, but that's why we call it that. You could call it keyboard, you could call it user, anything that's semi-appropriate. So that line, looking exactly as it does there, will create a scanner object, whatever an object is and whatever a scanner is. In previous versions of this class, there was something that looked like this. In particular, you notice the difference. Instead of new scanner, it says scanner.create. If you're looking in older Java textbooks or older reference materials, sometimes that will pop up. This won't work. So always do this line, never do that one. So now we've created our scanner object, whatever that means. You only should do that once, just once in your program. If you do it more than once, it causes great big problems for the grading. Then anytime you want to read something in, you have a line that looks like this. Int(x) equals standardin.nextInt. Notice the I of int is capitalized, and that's the only capitalization there. Again, x obviously is anything you want it to be. It's a variable name. You get to choose. Double D equals standardin.nextDouble. Now we've talked about the 8 primitive types. Int, short, long, byte, Boolean, character, float, and double. Each of them have these next methods. For this lab, and generally we're mostly going to be using nextInt and nextDouble. But you certainly could do next Boolean, next float, next byte. But as far as this homework, this upcoming homework and the labs are concerned, we're really only going to care about nextInt and nextDouble. Remember, of all the 8 types, there's only 4 that we're really going to use. Int, double, Boolean, and character. Or if the variable has already been declared, so you say int x somewhere up above, you can later say x equals standardin.nextInt. Again, that will allow you to read it into, that will just allow you to read it in. And in particular, as the program is going through, the program is going to start at the top of the main method and go through step by step until it hits the end of the main method. When it hits one of these methods, the program is going to wait. It's going to pause until the user actually enters the value and hits return, and then the program will keep on going. So this is an example of a program that uses the scanner. And again, these are online too. This is online both as source code that you can directly download. Of course, the slides are there. So here we have our scanner creation line, right, just as we've seen before. Now, remember that the rest of this public class scanner usage and the main method, those are things that you just have to memorize. And then we have the scanner creation line. So every time the program is waiting for a value, meaning reading something from the keyboard, what we want to do is we want to tell the user, you need to input a value. So enter first value. And then it reads in that value. Then we read in a second value. Notice that we're declaring the integer here and reading in the value there. Then this goes and adds them up and prints them out. This isn't the most riveting program in terms of what it can accomplish. Wow, it can add 2 numbers. But the point here is that it allows us to see how the scanner is actually used. Again, for this homework, you only need ints. You're not going to need doubles for this particular homework. So I want to switch over to the homework again for 1 second. So we are providing you with skeleton code for this homework. We won't always do it. I think the homeworks we will, and probably the lab, a couple of the early homeworks and the lab quizzes. But essentially, the skeleton code is something that you should download to start working on. You'll notice that this skeleton code has some of the things that are needed for it, and if it didn't run off the left side of the screen, it would work even nicer. There we go. You'll notice that it already has public class weekday. It already has public static void main string bracket args. And all your code goes here. And you'll notice this line. Okay. So the only other thing that we need to keep in mind when we're using scanners is you need to put this at the very top of your program. Import space java.util.star semicolon. So the way Java works is it comes with a whole slew of useful functions. It has mathematical functions. It has input and output functions. It has functions that can encrypt things, decrypt things, all sorts of very useful routines that they provide. And they're split up into libraries. And we're going to see the libraries in a lot more detail. But essentially, the scanner class, or the scanner that we're using, is in the java.util library. And we need to tell Java to open that library so we can start using stuff from it. And the way we do that is we say import java.util.star, semicolon. And that's basically saying I want to be able to use anything inside the java.util library. It just so happens that that's where the scanner lives. This needs to be at the very beginning of your program file. In particular, so if you look at the source code that we provided, that the import line needs to be outside the public class line. Again, we're going to get into the exact details of that in a bit. You can have comments before it. That's totally fine. But the import line must look just like that and must be outside the class line. So we provide that in the skeleton code, so I'm not expecting people to run into problems. But in the future, as you're doing homeworks later in the semester, when we don't provide skeleton code, it is a problem that you might actually run into. Right, that's how you create a scanner. That was the code that I showed you on the previous slide. And then essentially use it through next int and next double. Any scanner questions? By show of hands, how many people feel more or less comfortable with using scanners? Okay, I'm seeing a good number of hands, not all. The lab talks a bit about it, and the homework talks a bit about it as well, as does the textbook. All right. So, a couple of the motivators for today. Doubt. In the battle between you and the world, bet on the world. Dreams. Dreams are like rainbows. Only idiots chase them. Failure. When your best just isn't good enough. This is another one I refuse to hang up in my office. Not surprisingly. Disservice. It takes months to find a customer, but only seconds to lose one. The good news is that we should run out of them in no time.
I don't get that.
I think what it means is the needle, like it's hard to find a good customer. I think it's implying that there aren't any customers left because they've been so bad in terms of disservice. I don't think this was the best and most appropriate picture myself. Okay. So what I want to do is go over a couple examples of programs. I have, I believe, 3 program examples. I'll probably get through the first 2 today, and the third one, which is the BMI calculator, we'll probably start today and then finish up on Monday, depending on how things go. So this program will convert temperature from one to the other. So I want to, right. So I want to spend a bit of time just talking about it. A lot of this is the same. We have the public class or whatever. We have public static void main string bracket args. And here we set our Celsius temperature to 28. We then have a formula to convert from Celsius to Fahrenheit here. 9 times the temperature over 5 plus 32. And then we display the result. Through a series of print statements, we print the result out to the screen. And if we were to actually go through and do this, it's going to take me a while to load up, so I'm not going to. But it'll actually print out that the temperature is something like 60 to 70 degrees. Question?
In your previous slide, why do you have the spaces in between the two colons? Not colons, the dash marks.
Where? Here?
No, on the bottom. What's the purpose of the space?
Oh, that just, you know what, I will run it.
Is that where something goes, where the answer goes?
No, so what it does is, so all it's going to do is just, it's sort of prettily formatting the output. So if you were to compile this, oh, my computer's kind of slow, it's going to take a bit of time, and then run it, come on, do it. You notice that 28 degrees Celsius is indented about 3 spaces. And the Fahrenheit temperature is indented about 3 spaces. So I know this is kind of hard to see in the back row, but take my word for it. The second line is indented 3 spaces, as is the fourth line. So that's really what this is doing, is that's just spacing it over a bit. For whatever reason, when this program was written, that's how the person wanted to do it. You could certainly write this all out in one line as well. So we run this program, and great, we know that 28 degrees Celsius is 82 degrees Fahrenheit, which really doesn't help us today because it's not 28 degrees Celsius or 82 degrees Fahrenheit out. In fact, it's more like 28 degrees Fahrenheit. So that being said, that is a program that doesn't take in any input. And you notice that it's really not the most useful of programs. Hence why we're going to further develop our programs and start using input via the scanner. So the next thing that I want to show you is the body mass index. And body mass index, as I said, is a ratio of the square of the person's, the weight to the square of the person's height. Now, all of this is in metric units. And essentially, a healthy person is between, say, 20 and 25 in terms of their body mass index. Greater than that, you start is becoming in the overweight category. Less than that is moving into the underweight category. The reason that this is used is, you know how you have all these statistics about how, 99% of Americans are, that's not 99%, but like, X number percent of Americans are overweight. Well, the way they do this is when they look at the census. The census that they do every 10 years measures somebody's height and measures their weight. So they can quickly run these through the body mass index and say anything over 25 is overweight. But as I mentioned, it's not really the most accurate because if you have a lot of solid muscle, as again Michael Jordan did when he was playing basketball, he was considered obese according to the body mass index because all it does is how much weight you have relative to your height. It's not perfect, but it works for this example. Right, so we have to do everything in kilograms and meters or metric units. So we're first going to develop this program. So look at a person who is 4.5 feet tall and 75.5 pounds heavy. Now that is actually a 14-year-old, as it turns out, and the daughter of an author of a different textbook. So there's a number of things that we need to know. In particular, we have the weight in pounds and the height in feet. We need to be able to convert that to the metric equivalents. So what that's saying is we need to know how many kilograms per pound and how many feet per meter. So it's roughly 3 feet per meter and about 2.2 pounds per kilogram, or 1 over 2.2, 1 over those going the other way. So those are the constants that will allow us to convert between pounds and kilograms and between meters and feet. Now you notice that those values are not going to change during the course of the program. So we're going to make them final variables or constants inside our Java program. So here we have a rough outline, an outline of the program. And here we have 5 steps that we're actually going to perform. We're going to set up the constants. No, wait, come on. Oops, come on, go back. We're going to set up the constants, which is the kilograms per pound and meters per foot. We're going to set up the person's characteristics, which were printed on the previous slide. Convert the imperial units, pounds, feet, to metric units, kilograms, meters. We're going to perform the actual calculation and then display the result. So you notice here what we've done. We've taken a big program, or a big problem, or a bigger problem. The problem being, what is this person's body mass index? And we've broken it down into steps. Here we've broken it down into 5 steps. In general, that's, as we're going to see throughout the course, that's really the essence of programming. You take a big program and you split it down into a big problem, and you split it down into successively smaller problems. So, let's start. Define the constants. These are the constants that were on the previous 2 slides ago. Notice that because they are final variables, meaning because they're constants, we name them very specifically. Kilograms per foot, everything's capitalized, and underscores for spacing. Now, for your homework, you actually don't need constants. But if you did, this is how you do it. And then we'll draw them this way. Kilograms per pound. Did I say kilograms per foot before? Kilograms per pound. And you notice there's a little lock there, just indicating that it's a constant. Again, this whole box is just for visualization. And meters per foot. Okay. That step's done. Now we want to set up the person's characteristics. We're going to declare 2 variables. And these variables are going to be this person's height and this person's weight in imperial units. So weight in pounds is 75.5. Height in feet is 45.2. We now have 2 more variables for a total of 4. These 2 variables being the height in pounds and the weight in feet. The third step is to convert to metric equivalents. And here we're going to use what we've declared so far to do the conversion. You take the weight in pounds, you multiply it by kilograms per pound, and you're going to get, not surprisingly, the metric weight. You take the height in feet times the meters per foot, and you get the metric height. So now metric weight and metric height are the height and weight in metric units. Notice that ahead of time, we don't have to know what it is. This program figures it out for us. So sometimes it's easier to have the program do this multiplication. I mean, sure, we could have sat there on a calculator and computed it out and then just entered it directly, but this is sometimes much easier. So now we have 2 more variables for a total of 6. These 2 variables are the height and weight in metric units. This is a BMI calculation. It's the weight over the square of the height. As far as we're concerned at this point in the class, if you want the square of something, just multiply it by yourself. So here, BMI is the metric weight over the metric height. Now you also notice that everything so far has been doubles, just because we're dealing with some sort of, we're dealing with numbers with decimal points. So now BMI is equal to the metric height over the square of the weight. Poof. It happens to be 18.25. This person being a 14-year-old doesn't really, the 20 to 25 range or whatever it is for adults. That being an 18-year-old, 14-year-old doesn't really apply. Then we go and we print it out. And here we have a series of 4 print line statements that's going to go out and print the person's height, the person's weight, and their BMI. You'll notice something interesting. Here, I have math.round BMI. BMI is a double. It's 18.2439, or whatever it is, right? It has a number of decimal points. Here, what we are doing is we are saying that we're going to print out, we're going to round it to the nearest integer and print that out. So anything 0.5 or above goes to the next highest integer. Anything below 0.5 goes to the integer below it. So it's actually going to print out what looks like an integer, even though BMI is a double. And we're also printing out their weight and their height. Right. So this is the entire program. Each of those blocks, if you will, or each of those stanzas, whatever you want to call it, everything that's between the spaces are the 5 steps that I went over. Any questions with this so far? Yes?
The plus signs in the print line,
Uh-huh.
what do they do? Are they significant?
Yeah, the plus signs in the print, so I'm going to go back a slide to chat about this.
Would you repeat this question?
Sure. The question was, what about the plus signs in the print statement? The plus signs in the print statement, if you want to print out many things in one print statement, just separate them by a plus sign. So this is going to print out 3 things. That string, and it knows strings because it's separated by double quotes. It's going to print out the value in weight in pounds, 75.5, and then this string that just says LBS for pounds. So the plus in the print statement just allows you to print many different things. The last print statement is going to print out 2 things. This string has a BMI of, and the rounded version of the body mass index. One sec. Yes?
For constants, the whole thing has to be capitalized. You can't have lowercase constants.
The question was, for constants, does the whole thing have to be capitalized? That is, so Java defines what's called the style guide, which is considered sort of good ways to program in Java. And according to the Java style guide, which is what we're following in this class, yes, constants need to be capitalized. Everything needs to be capitalized. As far as, Java's concerned, it doesn't matter what you name it. Java doesn't care at all. We in this course in the Java style guide care. So sure, you could program this somewhere differently in terms of making some lowercase, some uppercase. But in this course, we do want you to have the constants all caps.
Is that just so you can look through and see what
Exactly. Because this way, when you look at this program, you'll notice that when you sit there and you see this thing here, metric height equals height in feet times meters per foot, you can look at this and pretty quickly tell what's a constant and what's not. The constants are all capitalized with underscores. The non-constants are not. So that's why that style is set up, is so that people can easily look through it and say, oh, that's a constant or a final variable. That is not.
Earlier you were mentioning that though with the string with the quotation, and I was thinking of the first statement, the first line, string origin. That's why you use that for that.
So the question had to do with the fact that, so these are strings separated by quotes, and he was asking about the string bracket args. I'm actually going to hold off on that for a bit in terms of the explanation. We're going to see strings in a couple weeks. We're going to see the bracket in a couple months. I don't want to get too much into detail now because there's a lot of stuff that I want to get over ahead of that. But I promise you that you will see that at some point in the semester. Yes?
When we're writing code, are there any rules for alignment or indentation that we should follow?
Yes. So essentially, I haven't spent too much time talking about this at this point, just because there's a lot of other stuff to go over, but it's a fine time to go into it. When you're going over a program, we have the concept of blocks, and a block begins at a curly bracket and ends at a curly bracket. So this class is everything between the 2 corresponding curly brackets. The main method is everything between those 2 corresponding curly brackets. And essentially everything in a block, and we're going to talk more about what a block is later, should be indented the same amount. So you'll notice that everything inside this main method is indented the exact same amount. Specifically about, I don't know, this is about 4 spaces over. Whatever a tab is on whatever, on JCreator, that's fine. So everything that is in the class, which are those 3 lines, are indented 4 spaces over, and then everything in the main method are indented another 4 spaces over. And this allows you to visually see what's inside what. As we're going to see when we start getting into more complicated programs, having proper indentation will make a big difference. So if I were to open the BMI program, come on, there we go. You'll notice that, that doesn't really show it. Well, it's essentially the same thing, right? Everything in the main method is indented to a certain amount. There will be times when, let's see, here we go. There are times when things go past the side of the line. So for example, this statement here is all in one line, whereas this statement takes up 2 lines, right? Because the semicolon is at the end of the second line, and I made it take up 2 lines because it would have gone right past the right side of the screen. So in that case, the typical way to do it is you just indent the second line a bit to sort of show that it's part of the previous line. So that's the very quick rules on indentation. We will be getting into them a bit more later in the semester, like next week.
If you wanted to enter like different values, would you put a skip?
Yes, and in fact, that's actually what I'm going to get to next. The question is, if you want to enter different values, this is great if you are 75.5 pounds and 4.5 feet tall. And if you wanted to do different values, you'd have to put a scanner in, and I'm actually going to get to that next. Is there another hand being raised? Okay. How do people feel comfortable with this program so far? Okay, I'm seeing most hands. Right, and if we execute it, we find out that this person has a body mass index of 18. Really, it was 18.2439, but it rounded it to 18. Okay, so we talked a bit about names. In particular, if you have a variable that's a constant, it's kilograms per pound written out that way. All caps, spaces for underscores. I'm sorry, underscores for spaces. If you have a non-final variable or a non-constant, this is the way to write it, again, following the Java style guide. In particular, you take all the words. I mean, it doesn't necessarily have to be many words. If you're doing radius, well, that's just one word. But you take all of the words that it stands for, in this case, weight in pounds. You capitalize the first letter of each. You shove them together without spaces or underscores, and then you make the very first letter lowercase. That W, for example, is lowercase. So that's the style guide rule for regular variables. You could say the radius of the circle. In reality, you probably just want to call it radius. But if you, for some reason, had something that was 5 words, again, that's how you sort of shove it together. Okay. So let's see if my program crashes for this. Since we got our dusting of snow, I figured this was kind of appropriate. much about cars, but the moral of the story is that if you're going to pull something with your car, you're going to pull a car, tie it to the frame and not the bumper. Okay. Now not to move your car in snow. The funny thing is like the bumper started cracking early on. They're like, let's keep trying it. What's the worst that can happen? All right. So I'm going to take the BMI calculator, and I'm going to expand it a bit to allow for user input. Now, I might not get through this entire example because I only have 5 minutes left. But this example is probably the closest we're going to come to in lecture to what your homework is, because it takes an input, does computations, spits out output. Here is the version of the BMI calculator, which essentially is just like the BMI program we saw before, but it's going to ask the user for his or her body mass index, or weight and height. You'll notice that we've now split it into 7 steps. We had 5 steps before, but what we're going to, the 2 new steps are displaying the legend, setting up the input stream, and getting the person's characteristics. Those are the steps that are going to be new here. So, a lot of this we've seen before, and a lot of it is not going to change. In particular, we define our constants. This ellipsis in a comment just means that there is stuff there, but I couldn't fit it in the slide. We're going to convert it to metric equivalence. That's the exact same as the last example. Perform the BMI calculation. Again, the exact same. And display the result that I didn't have room for. So first what we're going to do is we're going to print out a legend. What happens is that if you run a program and it says enter input, you have no idea what it wants. Maybe it wants your height, your weight, your age, your birthday. So any program in this course needs to at least have a line saying what it is. BMI calculator, weekday converter, or what have you. Because again, if your program for the homework just says enter year, the user has no idea. Okay, granted, we told you to write the program. But if somebody else who didn't know it ran it, they'd have no idea what year, month, day they wanted you, that they were supposed to enter. So all the legend is a line or 2 saying what the purpose of the program. Doesn't have to be anything fancy. BMI calculator is fine. Set up the input stream, exactly as we saw before. Scanner standard in equals new scanner system dot in. And then we have to get the person's characteristics. There's 2 things we need to get, weight and height. So this says enter weight in pounds, and then it's going to read it in. Double weight equals send it in dot next double. Now notice every time we're reading something in, we need to specify what we need to specify what we want them to enter. This is basically saying enter your weight in pounds, right? I guess it is saying, not basically. Same thing for the height. We tell the user to enter the height in feet, and they go ahead and the program goes ahead and reads it in. So these yellow lines are the things that are new or different from the previous one. Everything else is the same. If we were to look at the full program, it looks like this. You'll notice this is why I didn't show all of it on the previous slide, because it doesn't quite fit all that well. But essentially, those are the new lines that were highlighted on the previous slide. Everything else is exactly the same as the previous example that we just went over. Okay. So then we open up BMI calculator, we run it. So I am 155. So you enter your weight, 155. You enter your height in feet, and it tells you what your BMI is. And this, wait, give me a couple seconds. I have 30 more seconds. This is a heck of a lot more useful because it tells you what your specific BMI is, not what the previous author's daughter's BMI was years ago. So, the last thing I want to mention is that the scanner has a whole slew of methods that are available. The only ones we care about for the foreseeable future, we want to be able to create a scanner. Scanner standard in equals new scanner system dot in. We want to be able to read an integer from the keyboard. which is the next int method. And not for this homework, but for future things, next int is here. We want to be able to read in a double from the keyboard. We'll see some of the other methods a bit later. This should get you through the homework. At this point, you've seen everything needed for the homework with 10 seconds to spare. Have a great weekend.